Hello. In this video, you are going to learn how to use bullet holes to determine the distance or the height of a shooter. In our hypothetical scenario, we are going to pretend that we have found a bullet hole in the wall, which is about 78 inches above the floor. And when we examine and measure the dimensions of that bullet hole, we find out that the width of the bullet hole is 18 millimeters and the length of the bullet hole is 19 millimeters. We also find some bloody footprints that are about 57 inches from the wall, and we are assuming that those are the footprints of our shooter. The first thing that we're going to try to do is determine the angle of impact. As you can see with our diagram of a bullet hole here, we have our dimensions laid out, which is 18 millimeter width, 19 millimeter length. Most bullet holes that we find in walls or appliances, they're going to be elliptical in shape, which means that the bullet came in at an angle. If they were, perfectly circular, then we know that our shooter was shooting at a 90-degree angle. So the formula that we are going to use is that we are going to find what we call as the angle of impact. And if we can take the sine of that angle of impact, it's going to be equal to the length of the minor axis divided by the length of the major axis. Well, the minor axis happens to be the width, and the major axis is the length of the bullet hole. When we plug those numbers in, we get the sine of the angle of impact is equal to 18 over 19. And then if we want to solve for the angle of impact, we are actually going to take the inverse sine. So in your calculators, you would plug in the inverse sine. So you might have to hit second sine and then 18 divided by 19. And when we do that, we are going to get an angle of impact of 71 degrees. Now that we have found the angle of impact, the next step is to find the angle of elevation. So the assumption is that most shooters are going to shoot a firearm from the height of their shoulder. And as I mentioned before, most bullet holes are going to be elliptical in shape unless the bullet was coming directly at a 90-degree angle. So if the bullet is raising or increasing in elevation, that's called the angle of elevation. If the bullet is descending, that's called an angle of depression. Finding the angle of elevation is relatively easy. Remember, the three interior angles of a triangle must always add up to 180 degrees. In other words, angle A plus angle B plus angle C is equal to 180 degrees. Well, we already know the angle of impact, and that angle of impact we've already calculated to be 71 degrees. The angle B is going to be 90 degrees, and that's the angle between the floor and the wall. So remember, our bullet was found, I believe, 78 inches above on the wall, and we're assuming that the wall and the floor are perpendicular to each other. That's why it's a 90-degree angle. And so what we're trying to do is calculate C, the angle of elevation. So if we take 71 degrees plus 90 degrees plus C, which is equal to 180, and we try to solve for C, it's just 180 minus 90 minus 71. So C is 19. Now we know our angle of elevation. The next step in solving our crime is to draw a sketch of the crime scene. Try to be really neat when you're drawing your crime scenes because they can get kind of messy with all the different measurements. But I usually like to start with just a floor and a wall. The next thing I do is I mark the height of the bullet. And remember, the height of our bullet was 78 inches above the floor. Next, we're going to mark the distance that we found those footprints. Those bloody footprints were 57 inches from the wall. And we're assuming those bloody footprints belong to our shooter. Now we're going to take that triangle that we had calculated before to calculate the angle of elevation, and we're going to transfer it to our sketch. Now the triangle is not drawn to scale, and if I were to do this really well, but it gets a little messy, is I would put this triangle right up against that wall, and this side right here would be equal to the distance of the footprints from the wall. Once I've drawn a rough estimate of my triangle, I'm going to go ahead and add the angle of elevation. I don't need to add my angle of impact. You can if you want to, but typically that just kind of is another calculation that's going to wind up on the sketch, and we are pretty much done with it. The only one we're worried about right now is the angle of elevation. Once we've added our angle of elevation, the next step is to find the opposite side of our angle of elevation. So the opposite side of our angle of elevation represents the height the bullet is above the shooter's shoulder. If it was the angle of depression, that side would represent the height below the shooter's shoulder. But in this situation, we're looking for angle of elevation, and we happen to have the adjacent side. So the adjacent side, remember, is equal to the distance the footprints were from the wall, and in this situation, it's 57. So it looks like we know our adjacent side, we know our angle, and what we need to do is find our opposite side. So it sounds like we're going to have to use the tangent function. So remember, the tangent of the angle is equal to the opposite side divided by the adjacent side. So in our situation, it's tangent of 19 is equal to A divided by 57. And if we solve for A is going to be equal to the tangent of 19 times 57, which happens to be 20 inches. So in other words, the bullet made a hole in the wall 20 inches above the shooter's shoulder. That's good to know. Now that we know what how much that bullet has risen, now it's finally time to calculate the shooter's height. Now what I've done here, just to kind of make room, is I've moved my my little bracket showing that A is equal to 20 inches to the right side of my triangle, and I've also added a figure. A lot of times if I'm doing this on the board or doing this on paper, I would just draw a stick figure. But because I'm using a calculator, I can cheat a little bit and find some clip art. If you remember back, the height of the bullet is 78 inches above the floor. And we found out that the bullet rose 20 inches from the shooter's shoulder. So we can calculate the shooter's shoulder by subtracting 20 from 78. And so in this situation, it looks like the shooter's shoulder is about 58 inches tall. Now that we know the shooter's shoulder height, now the last thing to do is just add the height of the head. And the assumption is that most people's heads are about 8 inches. I guess you could argue that some are bigger, some are smaller. But if we do that, then we can just add 8 to 58, and we wind up getting a shooter's height of approximately 66 inches, or he's about 5'6". Great job. With a little practice, you'll have no problem calculating shooters' heights or even shooters' distance using these formulas.